Hello, this is Carl Long, and today we're going to review a little bit about balancing and classifying chemical equations. And let me reposition this. And we're going to start with a simple equation where we have NaBr reacting with H3PO4. And that's going to produce Na3PO4 plus HBr. So we're going to break it down. And let's get a little bit closer here so we can see a little bit better. So we're going to put our single elements under the arrow. And we have H. And because this is a polyatomic ion, we're going to keep it together. So we're going to have PO4. And now we're going to count them up on both sides and see what we have. We have 1 sodium on the left and 3 on the right with that subscript there, which is hard to read. And we have 1 bromine on the left and 1 on the right, 3 hydrogens on the left and 1 on the right, and 1 phosphate on the left and 1 phosphate on the right. Now what we would normally do is balance the polyatomic ions first, and because we have 1 on each side, we don't have to worry about that right now. But so we can obviously see there's something wrong with sodium. We need more on the left, and what we do is we insert a 3 as a coefficient there and then remultiply. 3 times 1 sodium is now going to be 3, and 3 times 1 bromine will now be 3 bromines. Now we have an imbalance in bromine, so we have to put it on the 3 on the right side, on the reactant side. 3 times 1 is now going to be 3, and 3 times 1 bromine is going to be 3. And now we compare 3, 3, and 3, and 1. Now that was easy. And where we didn't do anything, let's put a 1. Then I'd like for you to box up your coefficients. And then on any multiple choice test, you're looking for 3, 1, 1, 3. Now what kind of reaction is this? Now we have combustion, where something usually is burning, and we have synthesis or composition, where we're making something. We have analysis or decomposition, where something is breaking down, or single or double replacement. On double replacement, you get 2 compounds and they're swapping partners to make 2 new compounds. So these are 2 new compounds, and so it's going to be double replacement. So we'll put double replacement here. And that's all we want to do with some of these equations. Let's look at another one. Let's do, on the second one here, we'll put this number 1, CaOH2, and it's going to react with aluminum sulfate. To make calcium sulfate, CaSO4 plus aluminum hydroxide, so AlOH parentheses 3. Now right away you can see a couple of polyatomic ions in this. So our first step is to write out your elements and your polyatomic ions. So we're going to write calcium, and then because hydroxide is polyatomic and it's on both sides, we can keep that guy together. And then we got aluminum, we'll put right there, and sulfate is on both sides, it's polyatomic, we will keep him together. And now we're going to count up how many we have on the reactant side and the product side. So we got 1 calcium on the left, 1 on the right, so that's good. 2 hydroxides on the left, and 3 on the right. So that is not balanced. And we've got 2 aluminums on the left and 1 on the right. And we've got 3 sulfates on the left and 1 on the right. So right away we want to balance our polyatomic ions, which, let's go with sulfate because that's going to be the easiest one. So we want to put a 3, we want 3 more, so we're going to put a 3 in front of calcium sulfate. We cannot insert this as a coefficient because that doesn't work. That changes your compound, and it would never match. So 3 times 1 calcium is now 3 calciums. 3 times 1 sulfate is now 3. So that takes care of sulfate, but calcium is out of balance. So we need to get 3 calcium. So we're going to insert a 3 as a coefficient from calcium hydroxide. Now we're going to remultiply. 3 times 1 calcium will be 3. 3 times 2 will be 6 hydroxides. So we're going to put 6 here. Okay, and so now calcium's good, sulfate's good, but and aluminum is short, and so we're short on the right side as well for hydroxide. So we're going to insert a 2 as a coefficient. I should have put more space there. 2 times 1 aluminum is 2. 2 times 3 is going to be 6 hydroxides, and voila, everything is equal. We're going to put a 1 here because we didn't do anything with aluminum sulfate. Let's box up the puppies. And on a multiple choice test, you are looking for 3, 1, 3, 2. And that's going to be your coefficient ratio or your molar ratio or your mole ratio. It's known by all 3. So now what kind of compound, what kind of reaction is this? Well, we've got a compound and a compound reacting, and they're swapping partners to make 2 new compounds. So again, this is going to be a double replacement reaction. Okay, and let's try to do one more on this short video. Let's do number 3 here. We'll take magnesium as it reacts with Fe2O3. And that's going to produce iron, or iron's going to get the boot here, plus MgO. And we've got to remember the rules. It's +2 -2, so they're even. So that's why they're going to make a compound here. And we'll talk about the valence numbers and how we make compounds, ionic compounds, on another video. But anyway, let's go ahead and add this up. You've got magnesium, iron, and oxygen. Count them up on both sides. 1 and 1. Right there. And then iron, we've got 2 on the left and 1 on the right. Oxygen has 3 on the left and 1 on the right. So right off the bat, there are no polyatomic ions in here, so we don't have to worry about that. So we're going to insert a 3 as a coefficient right here. 3 times 1 magnesium will be 3. 3 times 1 oxygen will be 3. So magnesium is not balanced, so we can obviously put a 3 right here. 3 times 1 is going to be 3. And iron is not balanced, so we can put a 2 as a coefficient for iron on the product side. 2 times 1 is going to be 2. And 3 and 2 and 3. This was pretty easy. So our molar ratio will be 3. Let's box them up, make it easier for me to read. So 3, 1, 2, 3. Coefficient ratio, mole ratio, molar ratio. And what kind of reaction is this? Well, we know it's not double replacement because that's not a compound and that's not a compound. But we have a single element coming in and replacing another element and then getting to be with that other element. So it's going to be single replacement. So iron and magnesium are going to compete because they're both positive. They're competing over the negative oxygen. But magnesium is more reactive, so it's going to give iron the boot, and magnesium will end up getting the cheese. So this will be a single replacement. Reaction. And there we go. So I'm going to stop it at 10 minutes here, and then we'll make another one.